Welcome everybody. Today I'm going to do a little bit more review on the homework assignment. There's 2 points I wanted to cover, and then jump back into linked list more. Start writing some linked list code, getting a better feel for why they're good, so that we can prepare you for a linked list homework assignment on Wednesday, or on Monday. I will be getting a quiz out the door tonight. This will be a Chi-Tester quiz. As you know, 5 or 6 questions. Take it as many times as you need to, but only 100% counts. It's obvious, it's nice to get them done, but know that those quizzes are only 10% total of your grade. They are not a killer. So if for some reason if you get stuck, hit the discussion forums. But if you miss a quiz, it's not nearly as bad as missing an assignment. In other words, 4 missed quizzes tend to equal 1 missed assignment. All right, before I always start, any questions from anybody? We have someone's mic is turned on. I'm going to guess it's Matt. I'll mute him. How about that power? All right, we have homework questions. The first question, it's more of a comment. I made a mistake when I was drawing out. See if I can go pull up all my pictures that I was doing. Let's see, that was our cache. Remember we worked on some examples in class of how to do a course stack and course queue. I had some data members, and I called one of my data members size. That's an unfortunate name, because you also have a method that I insist be called size. You cannot have a method and a data member be the same name. So the solution is, don't call it size, call it something else.
Size 1?
Sure. Underscore size, private data member size, whatever you want to call it. Just give it some other name so you won't have naming conflicts. Point number 2. A lot of people are confused how to work with, and I've seen this numerous times while helping students. I am trying this semester to ensure that every homework assignment at least compiles when you get it, because students really appreciate a compilable and runnable assignment. And so they wonder, what do you do with these base classes? You don't do anything with them. You leave them. You don't touch them. You don't modify them. You don't copy and paste code from them. They are just there to help things compile and run. What you will be doing in your homework assignment is that you have to override these methods. You have to make new versions of them. So for example, in push, for example, you will need to have in your class stack your own void push that takes a const t reference item. So you will need to supply your own declaration, and then below supply your own definition. And that will properly override the base class. Do not try, a lot of people, I saw this multiple times as well, people were doing, trying to override the base class's version of it. That's not correct. Leave the base class alone. You want to override, or work with your own class's instance of it, or version of it. Does that make sense? As a side note, other languages have something called interfaces, which is more of a way of saying, it's kind of what I was trying to do here. An interface is a way of saying, if you want to make a class, great, go ahead, but you have to interface with this guy. And this guy says, here are all the methods you have to have. So you can make the class do whatever you want, but it insists you must have these methods in it. C++ does not have interfaces. Their approach for interfaces is basically a base class. Often what they'll do is they will do something like abstract classes, where that doesn't really help you with compiling and running, but it does say in order to use this base class, you have to provide your own version of this. I want yours to compile and run, so I don't do that. That's just the history of where we came from. So is everybody clear that you have to basically write your class as if you weren't inheriting anything at all? So you'll be redoing everything that you see up above. Brandon?
And it's generally better to, like you just did, declare and then define separately? Or
It's a style thing. Most languages do both together. In the C++ world, you will find them separate. And there's a reason for it. It's because usually you should be making these .h files, and .h files you can distribute out to people, but the CPP files you keep for yourself and you compile. It's kind of unique to C++. You can put it all in the class, but you'll be seeing me putting them outside the class.
So then do we put the array on the free store in our class?
This guy?
Yeah.
Yeah, I made a mistake and I gave it to you, but
Okay.
if you want to make your own, go ahead.
Okay. So it doesn't matter either way?
Correct.
Okay.
In future ones, I'm going to be taking these out of the base class. Yes?
I just used the scope resolution operator and access to one in the base class.
That works too.
Okay.
Yeah, I was trying to type this up and I accidentally left that in.
Okay.
I wish if I reuse this assignment in the future semester, you'll be getting that. It's hard to get these assignments perfect. I did hear earlier today, and I want to confirm, you do need to have a destructor. I don't have a test in here for the destructor. I don't test to see do you have any memory leaks? But you do need to have a destructor, and if you find it crashes in your destructor, that doesn't mean your destructor is wrong. It usually means you wrote outside of array bounds, and you were getting away with it until you try to clean up memory, and then it realized there's a problem, and then it crashes. If you need help with your destructor, take a look at the safe array example from last week. That one largely, almost more or less you can copy and paste from it. All right, did that trigger any other questions anybody wants to ask? Yes?
So do you just have those base classes to show us what methods we need?
Yes. I mean, in my world, what I would really love is some way that I could compile this into some way you can't read it, but then if you try to compile it, it wouldn't let you until you get it in, you specify it. I want it to compile, I want it to run, and I'd like to keep it as clean as possible, and this is the best answer I can come up with. The alternative is I give you a big blank file and a big PDF. Students kind of like that, but it's harder to work with tests. No other questions? All right, let's jump into linked lists. Last time we talked about arrays, that they can be good and they can be evil. As a review, what are arrays really good at? Speed. And why are they fast?
Locality.
Locality is one reason. No overhead is another. It's just arrays are basically, here's a chunk of memory. All your data's in one spot after another. There's no extra headers, no data members, no little bits that says here's the beginning, here's the end. If you did C strings in 1410, those do have one extra byte on the end. That's a null, a 0 byte, to say here's the end of the string. But regular arrays don't have such a thing. And you remember how locality works. If you go request some piece of data out of memory, it doesn't just get you your piece of data. It will return for you a 64-byte cache line, which is then brought into your caches, so that the next time you try to grab data, hopefully you can find that data still in your cache nearby, not far away. If the L1 cache gets all used up, you might find it in L2. If that gets used up, you might find it in L3. And some systems don't even have an L3 cache. I don't think I've ever seen an L4 cache. Yes?
And is the stuff that gets done from L1 to L2 and so forth, is that based off of last use?
There's a whole... Take an operating systems class. You can get PhD topics on this.
Oh, nice.
So I'm not going to get into it. Just for now, imagine whatever system that works in your brain, and it will be good enough for this class.
Okay.
Just know that it will always be there somehow. Other questions? All right. So we started talking about how linked lists are designed to do all the things that arrays do terribly at. But it comes at all the cost of everything that linked lists are good at. So linked lists are designed to shrink and to grow. You need you need to add one more item. You need to cram an item into the middle of it. Linked lists know if they've gone outside of bounds. but you have to do your own allocation and deallocation. They have more overhead involved, and so on. And the whole idea behind a linked list is that we are going to be creating simple little objects that I can represent like this. So it's called a node, and the node has a data and an address. The address's job is to point to other nodes. So you can think of this as like a one-way link, or a one-way chain. I don't know if there's any such, I can't think of a real-world object where everything chains together, but you can only see the chain in one direction.
Could you have them point backwards to?
You can.
use
We'll go.
numbers too?
That's the advanced topic for next week. Yes, you can make them. You could. People get into this like, wait, you can start adding another pointer to do this. Yes. Could you also add a pointer to do that? Yes. Yeah, it opens up a whole new world.
Everything
You don't want to do
was.
that.
I know.
So yeah, you could make them point backwards, but we won't right now. We're just going to be doing singly linked lists. I guess the closest thing I could think of is veins in your. Did you know that your veins? I've been told this in elementary school that you can't push blood against your veins in the opposite direction. I don't know. Someone with a medical degree can say, yeah, that's like the taste bud zones on your tongue. It's all fake, but that's what I've heard. I'm trying to imagine that once you go forward, can you go back?
I mean,
Squeezing
Took a
toothpaste out of
random-
it too.
You could cram it back in there.
But like,
Realistic.
sharks never swim backwards.
that's,
But the sharks chain together.
no.
They could.
I need a good real world analogy of things chaining, but only in one direction. You can only look forward, but not backward.
It's like swaying wagons.
Like, or like chains that are just hooked.
I know.
by gravity.
Horses.
Hmm.
Horses on those like when they do horse and carriages, if they ever have them all lined up and they put those little eye blinders on the horses, and they're chained up, so can a horse turn around and see the one behind them? No, but can they see the horse in front of them? Yes. That's the best I can come up with. You got a better one, let me know. It's going to eat at me all class period. The whole point here is, yes, they link together. It's fantastic. Can you insert nodes very easily? Yes. Can you remove nodes easily?
Yes.
Can you tell if you're outside of bounds?
Yes.
It makes sense. So you don't even know if you're out of bounds. You can't get out of bounds. But can you go backwards?
Supposedly yes, but
On this one, no.
No, on this structure, no. If you're at this node, do you have any idea who's pointing to it? No knowledge whatsoever. You can't figure it out with what we've got designed here. So we're going to extend this. Our linked list object is actually going to be two objects, two data types. We will have a node data type, and we will have a linked list data type. I'll try to color code this. Let's do linked list in blue. This is our linked list object. I will have 3 data members. You can get away with this with 1 or 2. I'm going to do 3. And I will also have some nodes. I will draw nodes in red. Is everybody okay with this idea of me using a picture or a pointer as an arrow? In reality, this data member is just an address, and if you go to that address, you find the next node. But you find it's easy to represent the whole concept of that by saying, hey, that's a pointer, and it actually points to something else. They can be wherever you want to place them. Typically, though, linked lists, oh, that's one of my criteria I forgot to mention. Arrays work really good on stack or heap. Linked lists, really hard to put a linked list on the stack. You need to create all these objects one by one. You can't just, how do I say it? These things need to persist. They need to live and die outside the scope of your program. You need to create them on the fly when you need it. That requires dynamic allocation. Therefore, these are going to go on the heap. This guy, the linked list, may be on your stack, but for the nodes, almost certainly are going to be on your heap. Now, I also represent null pointers as an X. This is basically a way of saying it has an address of 0, but it can't point anywhere. and simple.
Okay.
2 of my data members, should I call it front, back, head, tail? I think front, back makes the most sense. First, what do you guys want? Front, back, or first and last?
First one, best.
Let's take this as a crucial vote. How many want first and last? Raise your hand. 1, 2, 3, 4, 5, 6, 7. How many want front, back? 1, 2, 3, 4, 5, 6.
7.
Oh,
Did you vote twice? Did anybody vote twice?
vote the first
All right, online students, someone be the tiebreaker.
Start back.
No, we're not doing it. Whatever you say, whoever gets to answer first. Anybody? Then I will
Can I
call these
destroy
very
it?
confusing names.
Yes, that was my.
Flower and tree.
What would be the most confusing names I could give these?
You could
Front
say the
first.
front is the back. And the back is the front. That would be
Yeah.
confusing.
Last.
I'll do front and back. I will also keep track of I'll do count. I won't call it size because I might have a method called size. Count keeps track, an integer, unsigned int, how many nodes there are. Now it's entirely possible to do away with the count. You could easily just manually count up and figure it out. You could also do away with the back. You could just start at the beginning and work all the way down until you find the end. But for simplicity's sakes, I will add those data members on in. Does that make sense where we're going at? Questions on this so far? Yes?
So the one with the X, that's gonna be the back or the front?
He's the end of the line.
Okay.
He ain't pointing at anything.
See that line drawn from back?
But if you think of a line, or if you like, if you're a lunch line, the one in the very front, he ain't pointing at anybody.
What?
No, I know. I see this a lot too. That's a good question. I always still get exam answers and questions where people get these all mixed up. They get it backwards in their head. And you can technically make these things work in a real world opposite to how they are named internally. Just because I named it front and back doesn't mean you have to use them in that exact way. All right, let's start coding this thing. Let's go to a file. We're going to kill that guy. Start making a new one. Who left? Sarah left. Let's not say bad things about her. See out and down.
Why don't you do using namespace STD? Is there?
That's an old standard. This leaves it far too open-ended.
Okay.
I don't. There's actually a very specific good reason for it, and I don't know that reason.
Okay.
I've just been told C++11 you gotta name things exclusively because this can create more naming conflicts. You're basically doing everything, and you may not want everything. Sarah's back. Let's stop talking about her.
No.
You know, I think not getch. I need to stop using getch. IOStream has cn dot, what is it, cn dot get.
Isn't it like system pod or something?
I need to do using cn, yeah, cn dot get. But this doesn't press any key to continue, it's just press enter to continue. I think that's good enough. Let's do a return 0. I'm going to make sure this runs and waits for a press any key. Good. Excellent starting point. Now there were 2 objects that I mentioned. One is the node, the other is the linked list. The node we could technically make as a struct if you want to, because this node isn't going to have any constructors or destructors or methods. Things that don't do methods are by convention called structs. So let's do the same thing here. Template, type name T. I did that backwards. Type name T. We will call this guy struct node. Nodes are also public by default, so I don't have to say public. But I will need to give the two data members names. I'll call the first one data and the second one link. What will be the data type of the data?
T.
T. Whatever we want it to hold. And what do we want the data type of our link to be?
Point.
It's a pointer, but it always has to say pointing to what. You can't just say pointing to whatever. You have to say specifically what it points to.
Points
To a T.
Doesn't point to a T.
Well, no,
this is a
to a-
huge mistake. That
to a node.
Wait.
Pointing to address.
People make this mistake all the time. They say
Yeah.
it's pointing to a T. If that were the case, it'd be pointing to the actual data inside the node. That is not the case. It is pointing to the node object. Is that good for everyone?
So, this got confused. Isn't it pointing to the address?
It's-
Or pointer itself is the address?
Yes, and this just says what kind of data we'll find when we get there. It would be at an early level, you think, I don't want to say what I'm pointing to. I just want to have an address, and that would be the answer. This is ridiculously dangerous and scary and bad and ugly in lots of ways. I promise you don't want it. Unless you really do want it, then it's a lot of fun. But I will do it that way because that helps the compiler, helps everybody out, makes life much better. Now to be picky, you could say node T, but the compiler's smart enough to realize, well, obviously nodes are only they're templates anyways. I know I get that. I don't have to specify the T here. And I will call it a link, and I will also give it an initialized value. Matt asks, what is the node? The node is one of these red things. Let me know if that answer wasn't good enough. On your exam, you wouldn't be able to say a node is a red thing. Now, common mistake a lot of students make at this point is that you will try to initialize it to no pointer that way. That can't be done. You are not assigning code to link. You're not running code. This is a blueprint. It's a definition. In blueprints or definitions, you can say, if you were to make a link, here is what the data would be. That's not done with an assignment. It is just done with. In curly braces, you can initialize values with. You say, here's my data. Here's what it's going to initialize to. That's how you do it. You know, there is a way. And I showed it to you here. If you put curly braces on this guy, then that will initialize it to that data type's default data, if it has one. So we can try it. We can put the curly braces here, just so if it's a string, it initializes to blank. If it's int, it initializes to 0. May not be a bad idea. We can try it. I've honestly not experimented with this much. Are we good on the node data type? It's nice and easy, nothing fancy. No questions? All right, let's do the linked list data type. How many data members does our linked list have?
3.
What are their data types? What's front's data type? No. Unsigned in, look, it's got an arrow in it.
It's a pointer.
It is a pointer to what kind of data? All
Node.
pointers are only half the pointer to what?
So no.
To a node.
To a node. What's back? What's its data type?
Same
Pointer
thing.
to
Pointer to a node. What is count's data type?
Unsigned in.
Unsigned int. Let's do that. So we will have a template class. We will call it class linked list. Public and private. Our private, we had 3 data members. The first one was a node pointer called front. Is that what I called it?
Mm-hmm.
A node pointer called back, and an unsigned int count. Let's throw some initialized values on these guys. In your 1410, you may have seen this be null, spelled out in caps. C++ 11 gave us a slightly better null pointer, which helps figure out some problems that we'll never run into in this class, but I like to use that. By convention, it's better. Count is 0.
Can I
No
know this-
questions.
With,
I'm still doing too well.
with ints, I know that you can do like a normal int and set it to something, set it to 32, 28, some integer.
Sure.
And you can use the equal sign. So can you help kind of clarify what's the difference between initializing it with the curly brackets versus the equal sign?
The equal sign is assignment. It's not initializing. It's actually running code and writing a value to an actual variable.
Oh, okay.
Classes don't exist. They are blueprints. If you have a blueprint of a house, do you have a house?
No.
If you have a recipe for cookies, do you have cookies?
Okay.
No. But if you have a recipe for, say, M&M cookies, the best kind, and you make a dozen of them, now there's some terrible cookies. What are those dumb cookies that are sugar cookies? They just take a Hershey's Kiss and put in the middle. And they say, and people they always give them at parties, and you're like, it's got chocolate, I'll eat it. So it's a good example because it has a cookie and it has a single Hershey's Kiss in the middle. Okay. If you make a dozen of those, now you've instantiated 12 of these objects, and now you actually have each object has a real Hershey's Kiss, rather than the blueprint, which is not real.
Okay.
So this count is not real. It doesn't exist. It doesn't make any sense to assign it because there's nothing there.
Gotcha. Okay.
So this is simply saying this is a declaration or definition that if you were to have a count, then you would assign it. So it's trying to be really explicit, and C++ is good about being explicit. If you're really assigning something to real things, you use the equals, the assignment operator. If you're just initializing it when it gets created at some later date, use curly braces.
Cool.
Does that help?
Yes, very much.
It's an excellent question. Others? All right. Some of you still like the way that Java did it. And in Java, this is actually another constructor. So what they'll do is if you use the debugger, you'll actually see it'll run this, and then it runs your other constructor. It's almost like splitting your constructor into 2 parts. Now, I don't like that. It's ugly. Makes sense to a new programmer, but sure is a pain later on. Now, we don't need a constructor. When we start out with a brand new linked list, our linked list is really going to be this. Is there any need for a constructor here? Is there any extra object we're creating once? No. So our constructor doesn't need to do anything at all. So we don't need to supply one. We will need a destructor. That will be fun for another day. Not today. Matt, yes. Every node, if we create 5 nodes, we'll have 5 datas and 5 links. 1 per node. Since I don't have the destructor defined, I will comment him out. We'll work on him later. All right, we have created the declarations of the linked list class and the node struct. We want to use the linked list. We want to put stuff in it. And let's show you an example of how I can see me creating it. We'll create a linked list. We'll never be working with nodes here, by the way. You never want to let the user make their own nodes. They only work with linked list. What data type do you want to put in list? Should we do strings this time?
Yeah.
All right. Then I have to include string. It's It's not default C++, but it is in the library. std string. And then down below, we will say linked list of string. And I won't put my list on the heap. I'll just put it on the stack for now. I'll call it my list. If I were to have put it on the heap, I would have had to do it this way. My list is equal to new linked list string. It's a bit more work, and then I'd have to delete it. I'll let the stack manage it for me. And let's put some strings in there. I like putting pet names. Any pets that you have. So we could do push, we could do push back, we could do add, we could do insert, item.
Insert.
I think insert.
Insert, you guys like that?
Because aren't we going to want to put it in between things too?
Insert back.
Yeah.
I'll do insert back for now. Alright, I need a pet name. A real pet that's alive right now. Not some mythical one, not one to be silly.
Morphine.
What?
Morphine.
Morphine?
Morph-E.
Oh, I was confused. I was like, there's something about your life you
you
didn't
did
tell
this
me.
oh.
Did I do this in 1400 too?
Yes.
I don't remember. Morphe?
With a Y.
Like that?
There you go, yep. She's still alive.
What kind of pet is that?
It's a leopard gecko.
But it's not called Morphe. So, I shouldn't say this, but I'm going to. Long ago Zoloft was a headache medicine. It was not an antidepressant. And a family member of mine, she had headaches, and so they put her on Zoloft. And then they got a cat, and they said, "What do we want to name the cat?" And they like being silly and goofy, so let's name it after the drug Zoloft. And then later, the cat was a long-lived cat, and there was the commercials for it, Happy Dancy cartoon, and it was an antidepressant. And of course, the little 5-year-old boy didn't know any of that. He said, "Oh, I got a cat named Zoloft." That's how he knew. So they said in Thanksgiving, "What are you thankful for?" Write it out and draw it. So he said, "I'm thankful for Zoloft." Kind of got called to the office, had to get that one cleared out. They were more confused here. Can you name the cat Zoloft? Do we still need to keep this file open? Good cat. All right, let's keep going. Insert back. Hold on, we have Manny with a question. Yep, no pointer. Yeah, we're good. All right, another pet name.
China.
Oh, we have Blackie, like that.
IE. Thank you very much.
Does anybody have another pet that's
China.
like an EE on the end? No. What is China?
China.
Duke.
Hold on. What's Blackie?
He's a cat.
Okay. What's China?
Dog.
Dog. I had Duke.
Yep.
It's definitely a dog, right?
Oh yeah.
Better be. I'm gonna name my next cat. Get another one named Duchess. That'd be fun. All right. Other pet names.
Puka.
Really?
Oh, and you already answered though. We got one more. I want one more pet in here.
Great name.
Lynx Luther.
Lynx Luther.
It's a pun.
Well, we almost named my cat Condoleezza Kitty, so I. Lynx Luther, like that?
It's an OR, but yeah.
Like that?
Yeah.
Alright, what's Lynx Luther?
Lex Luthor?
Yeah, like
But
Lex.
what's Lynx though?
He's a lynx cat.
Oh, he's a lynx cat.
Yeah.
Gotcha. Alright. Oh, there's a whole bunch of pet names. Online students don't matter. Bobo the cat. You guys can put it in your own personal code if you're missing out on your pet. Alright, so the idea is that if I did a whole bunch of insert backs, what should be the order of my linked list? Who will be at the very front? Morphe should, because we insert back. So we will insert back initially, and that should have Morphe in there, correct? Why did you name it Morpheus? That would have been cooler. Is it a chameleon though?
No.
Well,
That's
that
the
doesn't
fun.
make any
That's
sense
the
then.
fun. It's a leopard gecko. It doesn't morph into anything.
Why don't you just name it cat? I mean, that's even fun. I don't know, sorry. So we'll have Morphe in here. Doesn't do anything.
Neither does the note.
Count to 1. Then if we do a pushback, what happens next?
They get
That's
Blackie.
another note.
Blackie, where does it push to? We'll have to create another node, put Blackie in here. That'll be a null, but we'll have to update that pointer to point to here. We'll have to update back to point to here. We'll have to increment count to 2. Whoops. Alright, if we add another one in, China, what will happen? We'll have to create another node and the back. Set that to null pointer. We'll have to update the back here. We'll have to update the pointer. Oh, that's so hard to do. Alright. Now do these pointers, do these nodes get allocated in the heap one right after the other?
No.
No. I'm just drawing it conceptually that it points, but these things, one could be pointed over here and it points back, and then this guy could point forward, and it could look like a real mess. But we don't have to worry about it. We just know if you go here to this address, then you can go on to the next one, you go here, you go on to the next one. Isn't there like games of clues, like what was like the world race or something that was on NBC 10 years ago? You had to travel across the world, find a clue, then travel to another part of the world.
Yeah, that's.
An Amazing Race. It's kind of almost like that.
Still on television.
Yeah, it's still going.
Is it really?
Mhm.
I never understood. What was that? Choose your own adventure books do that. Turn to page 42. Yep. Linked lists are much like that. That's why they're so bad with locality. When you ask for a node, you get this data and you get the whole cache line, but is there anything really used around that cache line? Almost certainly you won't have anything else useful. It'll just be garbage data or something else. Buffer space. So what we need to do is write an insert back method that accomplishes the goals that we just drew. Are we okay with that? We're going to have to go through this step by step and do it carefully. Linked lists take much more work than arrays. And that's not a bad thing. It's not a problem. It just means for you guys, it takes more effort. What was the name of the method?
Insert back.
What's its return type?
It does not have one.
Well, it's got a return type. Void.
Oh, I see. Yeah.
And how many parameters?
One.
What's its data type of the parameter? T. All right, so let's do that. What do we say? Void, insert back. I like to do more than that though. Const T reference. And you want to call it data item? We good? All right, let's start writing that method here. Template, type name, T, void, linked list, T, scope resolution, insert back, const T reference, item. Now with linked lists, anytime you want to write a linked list method, I want to hammer this into your head, and I don't know any other way to do it because I failed every semester trying. Well, some students get it, but it's hard to nail this in. There will be many scenarios, I'll say more than one scenario. Sometimes we'll have as many as 6 scenarios. Linked lists don't just come in a single block of code that solves all solutions. For example, there was one scenario when we were trying to insert a node but the list was empty. We didn't need to update a new pointer and update the previous link to the new pointer ahead of it. We had front and back pointed to the same guy. It was a lot easier to create a single node in an otherwise empty linked list. And there's a different set of rules if there's at least one or more nodes in the linked list. So we don't try to write one piece of code. We are going to be writing if statements to say which scenario am I in, and writing code for each scenario.
What about switch statements? Would that be better than if statements?
No, if statements are better. Switch is if you're switching on the exact same data member over and over and over again. We're not here. You're going to use logic. What scenario am I in? And so in order you write scenarios, write the most specific scenario first and the most general scenario last. It's very tempting to do this in reverse order. It's also good to try to identify all scenarios before you start. How many scenarios do we have here? David?
We know we have open, we have insert front, insert back.
No, I'm in the insert back method.
Oh, insert back. We have insert empty.
So we have an empty list. All right, what's another scenario?
We have, I guess, a one node list. It only has one node.
You're going to say a one node list.
Yeah.
All right, is there another scenario?
Multiple nodes.
Can any of these scenarios be grouped together?
Maybe 2 and 3 might be, but
Yes, I can tell you, just to get us started, that the one node and multiple node will be the same scenario. So I'm going to say at least one node. Which one of these is the most specific? The one that won't happen as often?
one.
Empty list. Which one happens the most often? Now you don't have to type out these comments every time you start a method. I just want you to go through this thought process. Alright, so let's do the empty list scenario, and let's get back to what an empty list looks like. If you've ever, linked lists especially, I said before, draw things out. Oh boy, with linked lists, it's almost impossible to solve a lot of these homework assignments without drawing it out. So we're going to get our linked list initialized to its starting state. Tell me, step by step, in order, every single thing we want to do to get our data or our list to work. What should be the very first thing we want? We'll do it picture-wise.
We'll have a node pointer to find.
Create a node. How do I create a node? How do I just make an object dynamically? The new keyword. So I have a node. Luckily our node does initialize to null for us. What else do we need?
A parameter for the name.
No, there's something before that. No, something even before that. We created a new node. Anytime you have the new keyword,
Oh,
it's usually a really good idea to store it as a pointer to something. So I will create another pointer. I'll call this guy temp or new node or whatever you want to call it. And he will be pointing to that new node we just created. All right, what's the next step?
Now the item.
Count,
What?
increment count.
Not yet.
have front.
Nope. I should be really mean to people as I... That's my dream of a computer that doesn't just give you an error message, the file wasn't found. No, it abuses you. It says mean things about your mother. It insults your intelligence in the way
Insert
you
the
look.
value.
I love using such just total smack talk. It'd be worse because you can't give it back. Yes?
So the node that temp is pointing to should be assigned as front and back.
There's something even before that. Let's put our data on in it.
Yeah, that's.
We didn't do it yet. It's not in my picture. We got to do
I said
it.
it in my head.
Insert
It's on
back.
my picture.
So we're going to do morphe. The gecko that doesn't morph. So So step 1, we create the node and assign it into our pointer. Step 2, put the data on it. Good. Now a lot of you want to jump into step 3. What's step 3 now?
Front point to 10. Or 10.
Front is equal to the same address as temp. So you can actually say front equals temp. Right? This guy has an address. How do I store the same address in front? Make a copy of it. Front equals temp.
I'm not playing with 10.
Now what?
Back equal times link.
Back equals temp's link. What is temp's link?
Is that
Temp's link is that guy. Is that what we want? Because it was already null, and if you say it equal to temp's link, it will overwrite the null with another null. It will do it. That's not what we want. What do we want?
front equal back?
Front equal back will work. Back equal no, front equal back is really bad. Because what's back?
Every time, no.
Back is null. So if you say front equals back, then it just assigns that null, and we lost track of our node.
So temp equal back.
Hold on. Let's go back. You say temp equals back. All right, that'll assign whatever was in back into temp, and now we lost. Now temp has done that. Is that what you wanted? Wouldn't it be fun if computers actually drew out what you're trying to? Is this right? No. Try this. Is that right? No. Unfortunately, it doesn't work that way. So what do we want?
Back to
Back to-
front or
So no, tell me the line of code. Don't say back to
Back
front.
equals.
back equals front.
Back equals front or back equals temp will get the job done. I will say back equals temp. All right, I shot you down too many times. You can do the last one. What's the very last one?
Just count.
There you go, increment count. The one I always forget.
Can you repeat one more time what's the difference between front equal back and back equal front?
Sure, so imagine that instead of this picture form, it's really this. Some hexadecimal address, and this guy is that. Okay? That address, in reality, if you actually go to this hexadecimal location, what do you find here? That node. So front has the address to where the node is. You good with that? So if I say back equals front, this is an assignment. So it's saying whatever's in front, make a copy of it and stick it in back. So now back will get a new value like that. You got it?
Yeah.
And if it's the other way around, it's a null.
Yeah, if you did back, if you did front equals back, then you're just copying the null pointer on over.
Just curious, how do you feel about chaining assignments?
You can do it. If you want to do something like temp, or you wanted to say front,
Front equals temp.
so you want to do it in one line of code, I don't care. In this class, it's not a big deal. Usually, if you want to get picky, I think in industry you write code for everybody else to read it.
Yeah.
And often code like this is a way for you to, and it's not much, but it's harder to read. And I would rather just do it step by step.
So I'm just trying to understand here the difference between temp and our actual node.
Temp is just a pointer.
Okay?
So it'll actually be written as node pointer t, I'll call it temp, is equal to a new, I'm going to run out of room, node t. That'll be my line of code.
Okay.
Does that make sense?
Yeah.
And I know this is confusing. A lot of you forgot the new and the delete keyword in pointers. This is a good review of it. You use the new keyword to create the object. This tells it what kind of thing you're making. It will return a pointer, and you have to hold on to that pointer in temp. You got it? So that's why I've got a temp pointer and also the node. But once these guys point to it, do I need to hold on to temp anymore? No. So do I actually delete temp to get rid of it?
No.
Well,
if
No, you just
use
let
it-
temp go away because that guy is really not on the heap. He's just a local variable. So he'll just naturally clean up because you got something pointing to it. We good? Lots of good review there. Are there methods for the node class? Matt? It is not even a class. What is the node? It is a struct. The node is dumb. It doesn't do anything. Just a collection of data.
Shouldn't we still have a constructor?
Why? Does it do anything?
Well, don't we need to?
Doesn't allocate. It doesn't make new space.
Yeah.
Your node doesn't need a constructor, and we initialize it nicely that way. So on node's creation, all I want is that that link is null. Okay, so let's do all the steps that we just drew. Oh, I also have to identify the scenario. How do I tell if I'm in scenario 1? A lot of people say, just look at count. That works, but I like to try to avoid even using count for my scenarios. So I can actually ask if front is equal to null pointer. You more astute programmers will realize that you can actually say if not front, because its pointers are is it not a 0 address. We'll make it easier for everyone to understand. Okay, so here is scenario 1, and I will name it as such. Do you remember all the steps that we just drew out? What was step number 1?
Make
Make a
a
node.
temp,
Make a node. How do I do that?
temp, or node T, star,
temp equals new node T. Yeah. Oh, that hurt.
Everybody got that? There's a lot of things going on here. Allocation on the heap. Operating system manages it, returns a pointer. You have to create the pointer, hold on to the address. The node is on the heap. Temp itself is not on the heap. Only the thing created with new goes on the heap. We good? All right, what was the very second step that I hammered you guys?
Give it data.
Give it data. How do I give it data? Act like I am just a dumb robot. You have to tell me what to type, and I type it. It's the future of voice automated typing. I'm really a slave in a box. Tell me what to type. Don't raise your hand, just tell me.
Temp dot insert
Temp dot
back.
insert back.
parentheses.
I heard ums, so I'll back up. That's what
Yeah, no, temp is a pointer, so we want to use the arrow operator.
And then data
Data.
equals item.
Yeah.
Questions on that? I know there is, and no one's going to ask it. I'll ask it for you. What does it mean by an arrow and not a dot?
No, I don't know.
Right? Why? Why do we have that?
It's a pointer. I
We're
can't
pointing
use a
to
dot.
that data that you
Why can't I say temp dot data?
'Cause that's,
It's referring to a member function, right?
Yes, so C++ is picky, and it's picky for good reason. Dot means go get the member of the thing. Well, what is temp?
no.
No, it's not a node. What is temp?
Pointer.
It's an address. Do addresses have data members?
No.
No, what do addresses have? They have an address. They have a hexadecimal number. Do they have anything else besides that?
No.
No. Does it make sense to say? It's like asking the number 4. Hey, 4 dot. Give me your stuff. It's like I'm a number. It doesn't. That's
I would don't kill me.
But what can you say? Or it's like if you have an address. Oh, where it.
What's there?
You like your address book.
What's the address for the White House again? 1600 Pennsylvania Avenue, I think. Right, 1600 Pennsylvania Avenue. Dot. Does that make sense? It's like I'm an address. I don't have anything. It doesn't make sense to say dot, but can you go to it and then go get to its data? Yeah, so there's two ways you can get to it. One is the arrow way. Go to it and get its data. If you don't like it, you can do it the manual way. You can dereference temp. And that goes to it, and then you can get the data, but there's one more problem. What does it do first, the dot or the go to, the dereference? It will try to do the dot first because of operator precedence. Is that what you want?
No.
No, so you can say, do it this first, and that works. Both lines 40 and 41 are equivalent. Which one do you like better?
40.
One with less typing.
Yeah, the one with less typing. 40 is better. The arrow is like a 2-in-1. It both dereferences and goes to it. If another way that helps you, possessive, good analogy. Temps, what is temp pointing to? Some data. Temp's data is item. Is that all right? If it makes sense to think of arrows as apostrophe S, do it in your head. It'll work. All right, so we assigned it our data.
Now we have front equal to 10. But the address of
Are you sure you have that in the correct order?
Temp equal to
Back
front.
equal to front.
Is this the correct order? I wish Regis on Who Wants to Be a Millionaire would be really jerk about that. Are you sure? Like the first question. No, that's obvious. Like, are you sure? I don't know. Just to get people to mess up and switch. They'll laugh maniacally.
It's the first
I've watched that show all the time.
It's the first
A trolling post.
I'm going with the first one.
The second one, making the
Yes.
whole point.
You win. Let's move on. Yes, that's correct.
So they want back equals 10.
Equals temp. And then one more. The I always
Yeah.
forget.
Count equals
Count plus
plus
plus.
4.
Count plus plus. We have written one scenario. Now we have to do the other scenario. What should I type for the other scenario? Please tell me what to do here.
Else if.
Oh yeah.
Or no, just else.
Tell me why. You said else if, then you said no, just else. Give me your reasoning for it.
Because we only have two scenarios. It's
Good.
either one or the other.
Good. That's excellent. And there's one more reason I like that. Do you remember my Microsoft Zoom example from last time?
Yeah.
If you only have one other thing left, you're really good to just write a general else statement. If you write an else if, I know you're like, oh, it's only going to be the other thing. But the other thing here is if front doesn't equal null pointer, and that's already clunky because you just ask that logic up here. And sometimes people even get lazier and they forget the else and they'll just do an if, and then you can get it to fire once here and then fire a second time. No, it's smarter just to say if there's only one last scenario, just do an else. I like that. So we have our else. This is scenario 2. At least one node. We have not drawn this yet. Let's draw it and solve it together. I promise, as much as you want to say, oh, I can do it, no. Draw it. I've tried many semesters of having students try to code it, and they can never do it. We will draw it out. We will return this guy to a cleaner form. Here's the state. There was a question, one pre-node. Yep. Matt, you asked a question a while back, and I ignored it. Why is temp not on the heap? Do you still have that question? How do I describe this? The easiest way to see it is only things that were declared with a new keyword go on the heap. There are really two pieces of data being created here. One is a node object, or node struct, and another is a pointer. So it's kind of like a 2-in-1 line. You're declaring two things. The node was declared with a new pointer. The temp was declared without it, so the temp goes on the program stack. It's a little variable, local variable. It lives and dies inside the scope braces of insert back. Actually, no, it lives and dies inside these scope braces. Once it hits the add-in scope brace, temp is not zeroed out. It's not deallocated. It just
It lives in front and back.
it just is on the stack, but it's now reclaimable garbage space. All right, we have at least one node. Let us write. Here's the state of it. There's no temp. Tell me step by step what we want to do. David, he's already on it.
We want to create a temp. We want to create a new node and,
You're going to create a temp that makes a new node.
yes.
All right? And that new node will have a null on it. Good. That's our first line. What's next?
Insert data.
Insert data. What was our next data? Blackie. All right? That is the current state of what we've done. What's next?
Back equal temp.
You're going to set back equal to temp. It's not,
Actually, I wouldn't do that yet.
I wouldn't do that yet either, David. Why?
First of all, I would set back pointer to equal 2.2 temp.
It's hard to see with 2 nodes, but we will really see with 3 nodes. We're better off, and we'll see this in just a minute, we're better off linking it before we update back. I think some of you see it. So what line of code do we want?
Back is equal to front's link.
The first node is equal to temp.
How
Back's
So
link.
you said back's link, is that what you said?
Uh,
If you remember, I forgot to.
I said back is equal to front's link.
No.
If you say back is equal to front's link, let's go through it. Front's link is null. So back will then become null. Is that what you wanted? No.
Can't you do that first node equals temp?
Well,
And then Murphy would be pointing to black?
David, what do you think?
you want to do
So-
back's link equals temp.
Back's link equals temp. Do you like that?
Yeah.
Is that what you're driving for?
Yeah.
See, wouldn't it be fun to actually have a computer you can just tell it to? It's like, no, I know what I want. And it keeps doing what you tell it. No, it's not. That'd be a good Twilight Zone episode. The world is controlled by robots, but only if you're precise. You're constantly getting so mad you can't be precise, and it's actually a hell. That's how almost all Twilight Zone's episodes are. This is really hell. Dun dun dun. Sorry. So we have back's link is equal to temp. So that will make a copy of, or back's link is this thing, is correct?
Yeah.
And I want it to be a copy of that. So back's link equals temp. That's where we are. Good, now what?
Back
And front equals.
Back equals temp. Good. One more.
No.
Increment count. Are we good? All right, do you remember all those steps?
No.
Yeah.
Let's try it. What was our very first step?
Create a new node.
Create a new node. What was our second step?
Insert the data.
What was our third step?
Half back equal temp.
Back link equals
Half
temp.
link.
Back arrow link equals temp. You got that? That confuses a lot of people. It's weird because you've never done anything like it before. I don't care. Sorry, just set yourself up. Backlink equals temp. What else?
Back.
Back equals temp.
And
Increment count.
Manny's excited. It's all making sense, right, Manny? It's because I'm a good instructor. All right. Did I miss any steps? We good? People are looking at it, letting it sink in. Get comfortable with it. It's like when you repaint a room in your house, you think it's ugly, but you let it sink in. Maybe it'll become better with you. Thank you. All right, now there's something else we could do. This is common. If you find in your scenarios duplicated code, I don't like duplicated code. So if something is going to happen every single time, we can just say, let's throw everything outside of it, either before or after. So is it sensible for me to grab these 2 lines of code and move it before the if statement? All right. What about back equals temp? Should that also come up here?
No.
I don't want to mess the order up because it's already after front equals temp. You might be smart enough and realize you can't. I'm not going to. No, don't be smart because this is back equals temp is very. The order is important. It comes after that line. So I'm going to grab those 2 lines and pull it out after. Right? Nothing fancy about it? Okay, let's see what happens by running our algorithm with a 3rd piece of data. We are going to stick in China. Here's the state of our list. Here is our code, which I will copy and paste into here. And we'll make it bigger. Temp has gone away. Here's the state of our list. Let's follow the algorithm, see if it works. What does it do? It'll create a temp, which is equal to a new node. And temp will know the address of it. Correct? Then what? Puts our data in. All right. Is front equal to null pointer? True or false?
False.
False. So it jumps here. Back's link equals temp. What's back's link? This thing. Back's link will now have a copy of what temp has. Back equals temp. Back will have a copy of what temp has. Count plus plus. Did it work? It did. That's pretty good. Are you confident it'll work a 4th time?
Yes.
Yes. We've written a nice set of extensible code. We can actually try it out. I am going to put a breakpoint right here on my cin.get. We will try to run this program. Compiled first time, that means it's guaranteed to work. And I didn't watch it go through the code, but the debugger is absolutely fantastic for debugging linked lists. I will mouse over my list. My list has these data members. There's a front address, there's a back address, and there's a count. Let's go look at the front. Front is pointing to who? Morphe. Let's go look at its link. What's that pointing to? Blackie. Let's go look at its link. China. Duke. Lynx. Luthor. And what's its link?
No.
Null. Can I go to null? If I try to, it doesn't make sense. Do we have a functioning linked list?
Yes.
Yes, we have a functioning method. 1. All right, what would you like to write next? An insert front, delete front, or delete back?
Delete back.
You want to do delete back? Any other choices?
Insert front would be, I mean, you can
Insert
do insert
front
front.
makes more sense.
Insert front sounds easy. You want to feel confident with yourself? What? Delete middle? No, we could do a delete middle. It's not a bad option. I don't. No, it's too much like a homework assignment. I'd be giving you answers if I gave it to you.
Do we want to like overload some operator?
Well, that's your homework assignment. Let's do insert front. I won't be mean yet. Oh no, let me give you. I'll narrow it to two. Do you want to do insert front or delete front? Both are relatively easy. Raise your hand if you want insert front. You did something? Let's do something just as easy. We'll be feeling good about ourselves. 1, 2, 3, 4. How many want 5? How many of you want delete front? You want to go for the power. 1, 2, 3, 4. We have 5 votes on delete front. Or insert front. We will do that. All right. I'm going to reuse these guys. I'm going to make a copy of them. I'm going to comment out these. I can comment them out by highlighting them. Control K, Control C. Very nice. It doesn't. Oh, I'm going to show you even more magic. I want to change all backs to fronts. I could do a find and replace with Control H, but I could also hold down Alt and do a block select. Hold down Alt and select, and then I will backspace and type the word front.
Nice.
It's like this made your whole tuition worth it just for that one moment. All right, so I have my insert fronts ready to go. Do you agree that this will basically reverse the order of our output?
Yes.
Morphe will be in front, then Blackie will be in front, then China will be in front, Duke, and then Lynx Luthor will be in front. All right? Another rule of programming. This is a Brad Peterson rule of programming. Copying and pasting is a tool of the devil. It will burn you. It will send you to hell. Do not copy and paste. It will cause you days of grief of debugging. You think, oh, I'm smart enough. I'm good at this. I can copy and paste and make the necessary modification. No, you're a prideful moron. Your pride will kill you. Don't do it. We will not copy and paste these methods and make the tweaks. We will manually write out the code. I can't tell you how many weeks of my life I have lost thinking I can copy and paste, and then later it takes me days to debug my mistake. We will write it out. We'll have an insert front. I will even type these out. I will follow my other rules. Specific and general. What is the specific case?
Well, we know we're going to add a new.
I will copy my comments. I think I'm okay. I think. If you do copy and paste, be absolutely paranoid and reread the line several times.
Well, no T.
Does it make sense that we will have an empty list scenario?
Yes.
Yes. Will it make sense, do you think, that we will have a more than one node scenario?
Yes.
I think so. Will we have any other scenarios past that? No. All right, let's write it out the manual way, not copying and pasting. How do we do our first scenario? How do I see if it's an empty list?
If front is no pointer.
Front is null is a great way to find out. Okay?
You also say if front equals back.
No, because that could also trigger a one node scenario.
Well. Sure.
You want to argue with me on that?
No.
All right. That's a wise decision, David. All right, so front equals no pointer. Let's draw it out. We'll get back to get rid of our code. We don't want it. Get back to our original state. Put the count back to 0 and get some nulls in here. All right, what should be the very first thing that we do?
create temp.
Create a node and have temp point to it. All right, then what?
And we insert the data.
All right, then what?
Then we check, see if front is equals null.
You're trying to do, no, we're just gonna do the whole scenario
Okay.
here. Keep going.
So then
Point-
we have
Point temp to count. No.
we point we have front equals temp.
You sure you have that in the right order?
Yes.
Good. Wouldn't that be like a horrible relationship to be in? Like your significant other just questions, "Are you sure that's the right choice?" I don't know. You're supposed to. Are you sure? Then what?
Back equals.
Are you sure that's the right order? Yes. Then what else? All right. Was that so bad? No. Let's write out our scenario. I'm going to scroll down so you can't see the code above it. Okay, what do we type? What's our first step?
Then temp pointer. Oh yeah, arrow pointer.
Temp arrow.
Data.
Got
Item.
item.
We got it? All right, now what? What was the third thing?
Front equals temp.
Front equals temp. What was the fourth thing?
Back equals temp.
What was the fifth thing?
Count.
All right, let's do the other scenario.
Else.
Let's draw it out. What will be the very first thing that we do?
New node.
All right, now what?
Insert
What the
data.
data?
Blackie. Then what? Temps link equals front. Is that what you want?
No.
Yes.
Yeah.
And then.
Yes.
Oh.
Then front equals temp.
Are you sure?
Yep.
Hold on, I gotta get distracted. See if I can find this.
Hello, I'm Leonard Nimoy. The following tale of alien encounters is true, and by true, I mean false. It's all lies, but they're entertaining lies, and in the end, isn't that the real truth? The answer is no.
I enjoy The Simpsons. All right. Constantly asking you questions over and over. So here we are. What do we want to do next? We just did temps link equals front.
So front
Front
equals temp.
equals-
Front equals temp. And
Count.
count plus plus. All right, let's write all those lines of code out. What was our first line? Create a new node. I know you can copy and paste, but you learn so much more if you retype the same line of code over and over again. Manually typing is great. Now what? Temps what?
Actually, data.
Temps data equals item. Keep going.
Temp link equals front.
Temps link equals front. Now what?
Front equals temp.
And?
Count plus plus.
Very good. Now can we clean this up?
Yep.
Yes, these two lines of code show up in both. So I'll pull up before. And the front equals temp. I can only grab the count plus plus and pull that after.
How come you can't,
Now, couldn't you pull out the front equals temp after that because you have, it happens both ways on regardless of which one it happens?
yeah.
No. Let me show you. All right, so we're going to back up a step.
So it's,
Okay,
I'm
hold on,
seeing
hold
below
on.
the where we have.
That's a good question, David. Let me show it.
Okay.
So here's where we were. We created a node, we put our data in, and this is where we were.
Yeah.
And you said, what if we were to do the, you want to do the front equals temp after the end, correct?
Yeah.
So you want to grab, oh wait, we could get it. Because it's already after here, correct?
Yeah.
This order must be after. Does this order matter up here?
No.
No. So could we have rearranged it like that?
Yes.
Yes. You were correct. This one time. I can edit the video, you know. All right. There we are. Let's test it. I think we have our code in place. We'll run it. Here we are. We should be seeing who should be at the very beginning of the list.
Duke.
Links Luthor. Then what?
Duke.
Duke, China, Blackie, Morphe, Null. Do we have it?
Yep.
All right. We are now inserting data into our list backwards and forwards. We don't have anything about inserting in the middle, deleting in the middle. That will be more homework assignment related.
So I guess the fun part now is deleting the front. Or
Yes, we
deleting
have
the
to write the delete front. Even more fun, deleting the end, and also a destructor. That can be for next time. Are there any questions on this? How's the homework assignment coming for everybody? Is anyone done? Who's done? Raise your hands. Handful of you. Who has not started, to be honest? One of you. Who's stuck? A handful of you. Stick around. That's why we have lab time. We'll have lab time on Monday as well. We have not done a participation code. I keep putting those to the end. I need to hide a mean name in the middle somewhere. I need some numbers.
7.
You want 7 more numbers?
7.
7 what?
7, 7, 7, 7.
123.
Who would guess it?
There we are. 777123 is the participation code. And as always, I never received any upset emails with my last lecture video where I ended early. I'm happy about that.
The one where you ended off mid-sentence was the best.
Actually, that said, there is a new program that Weber State has. It's a survey. They'll give you 5% of your tuition money back. You got to sit with them for about 2 hours of your time. It's a big survey, but 5% of tuition is a lot of money. You just have to go and visit their office.